Hello everyone, it's Sakai, and another day, another tornado risk in the Great Plains. It is May after all, so let's get into it. So first, we'll start with the SPC outlook, and as you can see, today's risk is a bit more notable than yesterday's, although yesterday had a strong tornado, which we'll dissect later. You can see that there is a 15% hatch tornado risk like yesterday, but there is a SIG 2 area, so they're more confident in the chance of a strong tornado today than they were in yesterday. Why is that? Well, let's look at the data and see why. So first, let's look at the surface map. And you can already see you have healthy moisture making its way further up. The warm front's like kind of like it's like kind of the good moisture's like staying right here and is currently progressing north into Missouri and into Iowa. But the main area, the main focus area is going to be here in northern Kansas to southern Nebraska, this area. So let's look at the models and see what we have to work with. So first, let's start with the HRRR, and let's just see the convective evolution. And again, I always start with reflectivity to avoid accidentally clicking on a storm or anything. Man, this is incredibly slow. It should not be this slow. So let's take a sounding here and let's dissect. Actually, no, let's not do that. Let's look at the dew point. And as you can see, here's our system. This system right here is the main trigger for severe weather. And it's a pretty classic plains dryline setup, but there isn't anything firing on the dryline. Why? We'll get to that later. Instead, activity is concentrated on this forecasted heightened area of dew points and moisture convergence over here. So it has storms initiating over here, but immediately a flash jump out. You can see that, like I mentioned earlier, the dry line or the boundary here is oriented northeast to southwest, which is not good and favors unfavorable, outflowy, stable initiation when storms do go upscale. So when storms do congeal into a line, they're expected to. I would not expect tornado potential. So already from the start, like when it comes to tornado potential, we're limited to any storm that can stay as isolated for as long as possible. That's what happened yesterday. We had a storm that was able to stay isolated for quite a long period of time, and it ended up producing a pretty strong tornado. Let's dig a bit deeper into the setup. Let's not go to convection yet. Let's look at what structure this has working with it aloft. So we have a decent trough. We have our decent trough right here. But the big issue here is that the strong 500 millibar from the trough is kind of initially only making it into like the Kansas part of the warm sector. So the best overlap between strong winds aloft and the healthy moisture in the warm sector initially is over here. So that's another reason why you're seeing focus for initiation there. There's just more lift here than there is down by the dry line and in southern Kansas. Let's look at the 700 millibar jet to see where initiation axes are especially pinpointed. This is taking its sweet time today. I have no idea why my Wi-Fi is so slow. My apologies. Okay, screw it. We're going to go to the NAM. And like I said, although the NAM has a pretty sus reputation, it is pretty good with its 700 millibar jet axis placement. It does have a usable 700 millibar jet over here, and kind of staying into Kansas, but maybe kind of venturing down into Oklahoma, but it is way too dry over here. But the good 500, 700 millibar jet axis stays in Nebraska to Kansas. So I would focus on Kansas and southern Nebraska when it comes to storm chances. And you can kind of see the same here. Initially, earlier on, it's concentrated in Kansas and Nebraska, this area, and it doesn't get over here. So focus on Kansas and northwards for initiation today. Why? I'm sure you saw that wonderful dryline feature earlier. Let's look at here, and you can still see that the best 700 millibar axis is concentrated there in Kansas. But we have a great dryline today and a pretty strong low. So why isn't anything initiating? It is May, and after all, it's May, man. It's pretty typical. We're not going to use HRRR because its drive ice is extremely bad. So scratch HRRR. Let's go to the wrap. And let's grab a sounding right here. Here, you can see our features better. The northeast to southwest oriented boundary, where we have the strong upper level winds for initiation. My goodness, this is unbelievably slow today. Let's go back. And let's get a sounding in Oklahoma. Oklahoma's not going to be able to do anything just because there's so much dry air aloft. There's still quite a bit of dry air at the surface, but most critically, there's just no support aloft. If we look at 500 millibars, you can see that there's literally just nothing over Oklahoma. And although that kind of does change later, by the time it does change, it's already getting way too stable, so you're not seeing anything. That's why you're going to have to focus on the Kansas boundary for initiation today. Just forget about Oklahoma. Oklahoma should not happen today, in my opinion. Now let's focus on the storms in Kansas. Initially, remember how we pointed out the boundary orientation earlier makes it unfavorable for QLCS tornadoes as things go upscale. So let's look. HRRR has some stuff going up over here. Let's grab some soundings over here and pick apart the environment. Again, I'm apologizing. My Wi-Fi is incredibly slow today. And there's just nothing I can, do about it. This is incredibly frustrating. Then you can see there are some pretty good profiles immediately because, we're near the boundary. There's a greater wind shift. So there's lots of streamwise vorticity and directional shear at the lower levels of the atmosphere. Also, because this area is just further removed from the area further south where dry air is being advected into a loft, follow the wind barbs. The air going into Oklahoma and southern Kansas is coming from New Mexico. Air going into northern Kansas is coming from more moist areas. It's not too dry, and you have a pretty good streamwise curvature. You have tons of instability, healthy 3 cape, and really good lapse rate. So today, expect updrafts to be explosive. And like I said, when you pair that type of explosive instability with any type of low-level shear, you're going to have to absolutely watch this area for significant tornado potential. So, honestly, before things go upscale, things do go upscale as, the LLJ ramps up, and as forcing from the loft becomes stronger and stronger. But I would watch for earlier storms in northern Kansas, because the lower level shear profiles in this area are unbelievably good. Now, one caveat is that did dynamic instability or winds aloft, they're still relatively weak. So storms might have some issues with going outflow dominant, and they're not likely to be as organized. So if stuff does end up merging pretty quickly or becoming slot mode, do not be too surprised if that happens. But still, with this type of explosive instability and that lower level shear, any discrete supercell that can maintain its discrete identity in this area in northern Kansas should have a pretty good shot at producing a significant to intense tornado. Watch this area to see if we could get a discrete supercell to stay isolated for relatively longer like we did yesterday. Now, there is stuff that initiates further south in Kansas. Come on, load. Website is just not working with me today. Come on. Now let's take a look, but then you see this is where you just have, actually that's way too dry. I don't believe that for a second. Ignore that. This is why you should not take the HRRR at face value. It is just criminally dry. So let's go. Yeah, Kevin, never use wrap reflectivity for forecasting. It's just way too dry. Hold up. Stop. Okay, nothing is working. I'm gonna try to get a new Wi-Fi route or something. This is quite annoying. But you can see just in southern Kansas, it's super duper dry. And why is it so dry? You just have to look at the advection pattern. You can see, follow the wind barbs back. That in Kansas and this area, if you just follow the wind barbs from this area and you can see where the air is being sourced into, it's mainly, you can see a continuous stream of a 50-knot jet, which connects this southern part of the warm sector to extremely dry air in the Texas Panhandle and in New Mexico. Because there's super duper dry air is being thrown from there into this area, it's just going to be pretty dry. So really, I'm not too sure that southern Kansas does anything. Really, I think the only good area for tornadoes today is northern Kansas. So really just keep your eyes peeled for any discrete supercell that can stay isolated in northern Kansas and move into that area. That should have a good chance at a strong tornado just because instability is so explosive and you have good lower level shear. But otherwise, I just think the rest of the risk is pretty cooked. That there's just no support for an Oklahoma risk, and southern Kansas is just way too dry, and the boundary orientation is pretty bad. Honestly, if I were to be honest, this might be a hot take, and I might eat my words later. I will not have this as a 15-hatch Sig 2 risk, but rather a 10-hatch, just Sig 1. But we'll see. I've been wrong before, and I'm very happy to admit when I'm wrong, and we'll see what the atmosphere has to say. But best chance for a significant tornado, any storm up here that can stay isolated. Thank you for watching.